Yeah, hope you're aware of it. Quiz number 3, all right? And I put a link under module 3, not module 4, yeah, because that's for module 3, all right? I give you more than 1 week. So the due date is next Wednesday, March 15, so next Wednesday, all right? Yeah. And another thing, for the homework assignment, I plan to give you our homework number 1 on Wednesday, this Wednesday, okay? Yeah. 25 question, that's the big assignment. Yeah. So different from quiz, yeah. So that's, pretty much covering all the first 3 modules, but module 4, probably half of the module 4, or at least half of the module 4. Okay, yeah, 3.5 modules, 3.5 modules, yeah, for our homework quiz number 1. Yeah. Number 2, mainly for queries. Number 2 is practice of SQL queries. After that, after spring break, we will do midterm, okay? Midterm after spring break, pretty much the first week of April. Yeah, first week, yeah. On my syllabus, I need to change the date, update. Yeah, the date on the syllabus not right. I need to postpone to make first, yeah, let's say, yeah, I'll check it. For right now, approximately first week of April. Yeah. All right. Today, part B of module 4. Yeah, so we keep that SQL query part. The title is More Select Statements and Insert, Update, Delete Statements. Yeah. The last 3 are much simpler. So we can, quickly, we use about one class, we can quickly complete the last 3 cases. Yeah. And then we focus on most of our time on select statements. Yeah. Very complicated. Yeah. All right, so let's start my presentation. Yeah. Okay. All right. B.1, resolving ambiguity in select statements. I mentioned this topic a little bit last time, the aliases. Today, let's take a closer look at this one. Yeah, so we, discuss a little more details. All right. First, let's look at a simple example. All right, so let me, yeah, I see a chat message. So let me just check it. All right, don't worry, Suma, I checked your name. Yeah. Suma Angela.
Okay, Professor. Thank you.
Yeah, because the only one missing is that Aaron Wicks. That's the only one missed at this point. Yeah. All right, so I hope, yeah, the problem, remember, yeah, whenever I do something else, I need to, restart my PowerPoint slides because my remote control is disabled. That's why I like to use, next time, that window. All right. Anyway, yeah. Example, handling ambiguity. Yeah. Here, I'd like to give you the whole story. Yeah. So last time only a little bit. This time the whole story. Yeah. Why ambiguity? First, I need to explain this ambiguity a little bit. Let's look at this simple query question. Yeah. Oh, I post that company database right under part A of module 4. The first link is under part A. Yeah, so you can find it. You can download that company.sql SQL script. Then you can install this database, right? So you create a database name, then copy paste everything in this file, and click the go button, you can install it. All right, pretty straightforward. Look at this question. For every project located in Stafford, there is a project table in this database. Project table, right? In that table, location, you can get a location information, Stafford, right? Yeah. Although there is a location table, all right? Yeah. List the project number, the controlling department number, and the department manager's last name. Yeah. Look at this relatively complicated query, more complicated than our first example. First, table join example. Remember last time we learned the table join example. Here, another table join. First, we need to identify the related tables. Tables mentioned in this statement. Those tables that can provide the information we need in the statement. Yeah. All right, so let's look at one by one. First, project table. A project number, project information. So the project table, we need to use it. Our table number 1. Okay, yeah. Then department table. Yeah. Yeah. Department information. Because department manager, we need to get the manager information from department table. All right. Department's manager's last name. Where do we find the last name, the name information of managers? No. Because a manager, it is an employee, right? A manager is an employee. So the manager's name we can find in the employee table. So the third table, employee. Yeah. Right? So here you can see we need 3 tables: project table, department table, employee table. So this is a 3-table join operation. In this 3-table join operation, yeah, last time I explained a 2-table join. But it's theoretical background. But how do we do 3-table join? Yeah, I didn't talk about 3-table join last time, right? But here we just use the same view. Yeah, but we need to extend it a little bit. 3-table join, if we extend the theory a little bit, we have 3 tables, A, B, and C. We do the Cartesian product first. Cartesian product on 3 sets. Cross product, Cartesian product, right? And more precisely on multi-sets, because our SQL table is multi-set. So we do Cartesian product on 3 multi-sets. Yeah. So that's the first thing. All right. Then after that, we know the definition of Cartesian product, right? Yeah, let me specify another time. All right. All right. For example, table A, we use this expression, a list of elements, A elements. Okay. Table B, list of B elements. How about that? Okay. Table C, a list of C elements. How about that? Okay. Then the Cartesian product, a list of tuple. Okay. A list of tuple. So the tuple with 3 components. First component from set A, second component from set B, third component from set C, and so on. Okay, each element is a 3-tuple element. That's simple, right? That's simple. All right. But after that, join condition. You need to specify join condition. Okay. Yeah. When you consider join condition between table A, table B, you need to have join condition number 1. Okay. Table B, table C, join condition number 2. Then you can join 3. You need 2 join conditions. Okay. You may argue, can I have join condition between A and C? Yes. Yeah. So A, B, C, but all right. So here A, B, C. Okay. 1 between A and B, 1 between A and C, 1 between B and C, but you just need two of 3. Okay, you just need 2 of 3. You can join. Yeah. 2 out of 3. That's enough to join, right? Yeah. Yeah. All right, but if you put a 3, you may make contradiction, right? Think about it. The third one probably contradicts one of the previous 2. That would be bad. Then you won't get anything. If you have some contradiction, nothing. It produces nothing. Okay. All right. But after join condition, selection conditions. Okay. All right. So with this theoretical disagreement, now we can write the query based on this understanding directly. Okay. All right. So let's do Cartesian product without join condition, without selection condition first. Okay. All right. Yeah. Here. All right. This where clause put all the conditions. Okay. Yeah. Before the where clause, from project, comma, department, comma, employee. That's the list of tables. Yeah. Okay. Yeah. Some students, when I gave them query assignments, because many students, they search the web to find closely related answers. Well, that's fine. Yeah. So those students, when they give me answers, yeah. So usually, yeah, because the examples you find in web, usually it uses the join keyword or inner join, outer join, yeah. So here you cannot see join, right? We do not have join keyword. Yeah. Later I will go there, because for the table join, there are many different types. Inner join, outer join, left join, right join, right? So different types. Yeah. But here we learn the simplest one. The simplest one, so actually what we are learning here is the inner join. Inner join is the default case. Inner, it's called inner join. The meaning I will explain later. Yeah, because the inner join is the default case, you do not need to write any keyword. It's the default. If we do not write any join keyword, that means we're doing the inner join. Inner join. Okay. Yeah. All right. All right, so that's the first two lines, just Cartesian product. Okay, the Cartesian product. Then join condition. So we need to specify two join conditions. The first one, D num equals D number. Yeah, but here we do not specify which table. D num comes from which table? In this one, for DBMS, no confusion. Because in these three tables, this D num only appears in one of the three tables. So DBMS won't get confused. So that's fine with DBMS. But for us, we do not know it comes from which table, right? You need to check the database definition. You need to go back to see, in three tables definition, which one contains this D num. Okay, yeah. So that's what we talk about, this ambiguity here. This is the ambiguity. It comes from one of the three tables. Which one it is ambiguous here? Okay, so we need to address that ambiguity, clarify it later. Yeah. So D num equals D number. Okay, join two tables. So then MGR underscore SSN from the department table, the manager's social security number for this field name. But if you go back to the employees table, that's the SSN. Okay, so we join those two tables, department and employee, using this join condition. Yeah. The first one, it looks like, project table and department table, right? It looks like project table and a department table. Join condition. Yeah. But it's ambiguous. Yeah. We need to guess. We need to go back to check the definition. Okay, yeah. But when we see it, this statement, it's not very friendly regarding the readability, right? Yeah. So we want to write better SQL statement. Okay, so we want to clarify table information on this table information. All right. Yeah. So all right. So to clarify it, the first try. So here, this first try. How do we make it, better understanding, better readability? The first try, use the table name to qualify it. Okay, qualify it. All right. Yeah. We just, before this field name, we put the full table name. Okay. Yeah. Here, add the qualifiers using table names. That's the first way. Yeah. You can make it more readable. Okay. Yeah. That's this way. Project dot table name, project table dot D. Yeah. All right. So we know that project, we do not need to capitalize it. Yeah. We do not need to capitalize it, table name. Okay. Yeah. Then department table, we use the full table name. All right. So here you can see, yeah, using the full table names, you can make it more readable. Yeah. All right. Yeah. But the drawback is when you have a long table name, you need to type the full table name. Okay. Yeah. So it's not very efficient. Okay. Yeah. So you want to save some type strokes. Okay. Yeah. So usually people like to save a little bit. See some typing, yeah. We use aliases here. Aliases, we can save some typing work, okay, yeah. So our next alias-based solution. Create an alias for each table name to avoid repeated typing of long table names. More efficient. Okay, yeah. So an alias can follow the keyword as. How to define an alias? There is a keyword as, but this as can be omitted. Okay. At the beginning, yeah. So people may like to put this as a little more to make it more readable. Okay. Yeah, but when people get used to the general way, some users, they may like to omit as keyword. Yeah. All right. Or it can directly follow the relation name. Yeah, we just omit the table.
Can we work on that unit or not?
Is it not noisy or not?
Yeah, I put a new motor in it and
But it's dragging right now, he's gotta rework it. They said you guys are gonna be out of here at 12:30 or 11:45.
that was the other
Oh,
proposal.
okay. So you're next one in line.
Yeah, next one. Yeah, but if it's noisy, can you delay after my class?
When you off,
1:45?
okay.
Is anybody else supposed to be in here after that?
No, as I know, no class
Okay.
after it.
Okay,
Okay,
that'll work.
I'm sorry to interrupt.
Yeah, I mean, merely just, All right. So directly follow the relation, and that means we can omit as keyword. Yeah, all right. So let's look at this version. Yeah, pretty straightforward, but for each table, we define their corresponding aliases. Yeah, project as P, department as D, employee as E. Yeah. In the from clause, we clear it, we make it very clear. Yeah. Yeah, we don't need more typing to give us information about these three tables. Yeah. But based on your logic, you can, if two tables both start with D, for example, right? Then you can use more than one characters, right? DA, DB, right? So yeah, so you have that freedom. Okay, aliases, you can use, but you try to use the minimum number of characters to separate those different tables. Yeah. All right. Yeah. And two different copies for, yeah. All right. So here. So yeah, actually it's done. Yeah. For that question, it's done. Yeah. So aliases. Yeah. Although later some people can omit as. Okay. Yeah. But still, even you can omit as to save a few more type strokes. Yeah. But some programmers, they like to add those keywords, okay, to make it more readable. Yeah. So that's of your choice, of your own choice. So if you feel I don't have any problem on the readability, you can omit. If some other people, they feel, if I put as, it can make me feel better, more readable for the logic. Yeah, so, yeah. So you have the freedom to choose that. All right. Two different copies of one table alias really needed. Yeah. Think about it. So here, there is one situation. You join two tables, but this time it's a special case. Two tables, they come from the same table. A Cartesian product with A itself, same table. That's possible. Remember, when we want to get a supervisor information, the supervisor information also comes from the employee table. Okay, yeah. So that's the E cross E case. The same table we use twice. Oh, we use 2 copies from the same table. Yeah. So let's look at one example here. Yeah. The first copy, employee as E. The first copy, we use alias. Yeah. So this time, if you do not use alias, you really get confused. You have to use alias. All right. Second copy, we use a different alias S. But this one, we know for supervisor's copy. Okay. Yeah. And how do we specify the join condition? Super underscore SSN equals super E, all right? Employee's copy, in the employee's copy, we look at a supervisor underscore SSN, okay? That should be the same as the supervisor's copy. We look at the SSN field, and we should join them, connect the SSN numbers in that way. Yeah. Okay. Yeah. So you can see this special case. Yeah. You cannot omit aliases. Okay. Yeah, think about that. Yeah. All right. B.2, set operations on queries. Yeah. So this time we need to combine some query results. Okay. The first query result, it is a set, or more specifically, more precisely, multiset. Second query result, another set, or another multiset. Then we can put them together using set operations. Set operations, yeah, to form a new query result. Yeah. So that's the B.2. Okay, all right. Using set operations to represent queries. Yeah. All right. Borrowed from mathematical set theory, but we need to modify it. Multiset. For duplicate rows, multiset. Yeah. So we need to keep that in our mind. Set and a multiset, that difference. All right. The first set operation, we call a set union operation. Union operation. Yeah. You know the meaning, right? Yeah. So if I draw a diagram, set union, A union B, okay? A union B, yeah, this part, okay? Yeah, first set operation. Second, set difference. Difference, we use except keyword for this operation. Yeah. So except, using a diagram, let's look at A except the B. In A, we remove the overlap part with B. This overlap part, okay? Overlap part, except A except B, okay? In set theory, yeah, if you get some math textbook, for this operation in set, there are 2 ways people write. One way just use minus, A minus B. But this minus is not regular minus, okay? Yeah, because the regular minus, sometimes people may get confused with the regular minus operation. So then some authors, they change to a different symbol, backslash. A backslash B to represent. So this is a set operation. It's not a regular minus. Okay, so when you read a math textbook, there are two different ways. Yeah. In SQL, we use keyword except. We do not use symbol. We use keyword. Okay. All right. Number 3, set intersection. Yeah. So that's the usual set intersection. Intersect. And you know the meaning. Okay. AB intersect. All right. Yeah. Yeah. But here, I want to put a note. Yeah. Make you alert. First and the third available in all SQLs. Yeah. But the second one, because it is a little more complicated. It may not be available for many DBMS. Many DBMS, they do not support this operation. So MySQL does not support. That's important for us. Okay. Yeah. So here, because our main DBMS, MySQL, does not support it. Does not support this one. That means if you want to do, because you may need it in your business, except operation, you may need it. You need to get around this. We can do the same thing. We get around it. Later, I'll show you an example. How do we get around it? Yeah, we can get around. Yeah. We use a different operation to get around it, but we need to do a little more work. Yeah. Yeah. But not too much more. Yeah, just a little more. Yeah, we can get around it. Yeah, you will see it. Yeah. All right. Yeah. Conditions for set operations. Here, in order to apply set operation, you need to check some conditions. That means not arbitrary 2 tables you can apply set operations. No. Because if 2 sets are not compatible, we cannot do set operation. Think about 2 tables, they may not be compatible. So there is a compatible issue here. Okay. Compatible. What do you mean compatible? Here, I give you a simple example. All right. If one table, you have 2 tuples, the structure. Another table, you have 3 tuple structures. They are not compatible. The number of components in their corresponding tuples are different. How can you join? How can you do the union? You can join, but you cannot do the union, except intersect. Not compatible. Okay, so we need to create a concept for the compatibility. Okay, yeah. So the concept we call the union compatible relations. Okay, yeah. You need to check the condition first. Yeah. How to describe union compatible condition? Yeah. First, they should have same attributes, same number, same names. Okay, the names should be the same. Other than the numbers should be the same, the names also should be the same. And other than that, the order should be the same. If you change the order, you cannot, not compatible. Okay, yeah. The attributes appear in the same order in both relations. Because if you change the order, we treat as different tuples. Completely different tuple structures. So they cannot be, connected using any of the three set operations. Yeah. Multi-set operations. This time we need to deal with the duplicate tuples. In table 1, yes, think about here. In table 1, the tuples may not be unique. You may have duplicate tuples. All right, yeah. These 3 tuples, they may have the same tuple values, okay? Table 2, think about these 2 tuples, same values. Same values, all right? But when you do set operations, how to address that detail? Yeah. So let's look at the multi-set operations. Yeah. Multi-set version, yeah. So here you can see the set version, these 3 set version. But when we move to multi-set version, add all to it. Union all, that's the multi-set version. Except all, multi-set version. Intersect all, multi-set version. But what's the difference? The difference. Now, the difference for the set version, the duplicate rows are removed, right? Because as a set, you do not allow duplicate tuples. So duplicate sets are removed. Or duplicate tuples are treated as one copy, one tuple. Okay, redundant copies are removed. Then you do set operation. That's the regular set operations. But for multi-set operation, you keep the duplicate tuples. You keep the duplicate tuples. Yeah. Copy 1, copy 2, copy 3. Those 3 copies, you treat them as 3 different tuples. Treat as 3 different tuples. Although they have the 3 same tuple values, but you treat as 3 different tuples in multi-set version. Yeah. Okay. Each tuple, duplicate or not, is considered as a different tuple. Okay. Yeah. Yeah. Look at that. Yeah. This is the key difference. Yeah. So sometimes people put a subscript, different subscript. Okay. T sub 1, T sub 2, T sub 3. Okay. Try to distinguish those copies, although they have the same tuple values. But when we list the query result, we need to keep all those copies. So that's the definition of the set operations. All right. Example, set union example. Okay. Look at this. Make a list of all project numbers for projects that involve an employee whose last name is Smith, either as a worker or as a manager of the department that controls. So you can see it's pretty complicated, this description. You need to spend quite some time to understand the meaning of a statement like this. So let us spend some time try to understand the meaning of the sentence. Make a list of all project numbers for the project. This part is easy, just project numbers. Okay, for some projects, then we need to select those projects that involve an employee whose last name, Smith, okay? Smith, last name Smith. We may have several employees with the last name Smith, okay? All right, 2 categories. The first category as worker Smith, okay? Second category as manager of department that control the project. Yeah, because each project, there is a department control this project. And that department has a manager. Then we look at the manager's last name. And then we only select those managers whose last name happen to be Smith. All right, think about that. All right, so here 2 parts. All right, the 2 parts we can separate. Can we do one at a time? Yeah, because if we do both together, it's too complicated, right? Let us separate to make it easier. The first time when we do it, we cut off the manager part, the manager condition, okay? Yeah, just the worker, okay? All right. All right, yeah. All right, yeah. So employee, right? Yeah. So we know each employee works for a certain number of projects, okay? Yeah. So we join project table, employee, then we check employee's last name, Smith, then we select. So that part pretty easy. So the second part, we need to put the manager information. Yeah. All right. So let's do 2 different cases. The first case, yeah, select distinct P number. So we want different project numbers, yeah, distinct P number. Project works on employee. Yeah. Project works on 3 table join employee. Yeah. P number equals P0. Join first 2 tables. ESSN equals SN, join next 2 tables. Yeah. Then last name equals Smith. Yeah, that's the first part. As a worker, like that. Okay. All right. The first query result. So we list that. Yeah. But the second, department manager. Okay. Yeah. Select distinct P number. This time we replace works on by department. Project, department, employee. Then this time join condition different. D num equals D number, join first 2 tables. Manager, join condition next 2. All right. Then, yeah, because here we select that manager's SSM. We specify that manager's SSM. All right. That employee must be a manager. So many employees who, if they are not managers, we remove from the query result. Yeah. After that, then last name equals Smith. Okay, yeah. So you can see, so these 2 query results. Then we apply set union operation. Yeah. Because here the set union distinct, remove the duplicates, right? No duplicate copies. Distinct, no duplicate copies. So then we can apply set operation here, union. Okay, yeah. So that's the way. So that's a typical example using the set operations. You may argue, so I feel some of you may argue or ask question like, is the first part, first half, the second half of this query statement, is the first half contains the second half? Yeah, because employee involved, right? Employee, there is a, think about logically. So because we know manager is also an employee, right? Is a special employee. Yeah. So probably the first half already contains the second half. Is it possible that, the first part is A, second part is B, B is inside first part? There is a possibility. I don't know. Yeah. So let's think about it. Yeah. Or we can run the query statement and check, if that is the case. Or we can run the first one separately, second one separately. So let's see if the first result contains the second result. If it contains, then the union, you just do nothing, right? The union, just the first half. Oh, sorry. Yeah, it's the first half. Yeah, the larger set. Intersection is the second half. Yeah, smaller set. Yeah. All right. But this example just gives you mainly the main point, gives you idea how to combine two query results if they are union compatible. First, union compatible because only one project number, P number, one attribute, P number, same name, same spelling, right? Same spelling. Yeah. No order issue, only one. So the order also the same. Yeah, it satisfies all the union compatible condition. Yeah. All right. Yeah. Okay. Then B.3, string pattern matching. Yeah. Another important part. Yeah. So this time when we specify select condition, in our select condition, we need to describe string patterns. And sometimes our patterns could be very complicated. Yeah. So in this B.3, so let's learn string matching pattern descriptions. Yeah. String pattern matching, using partial string matching. So we have two different ways. The first way, very simple, very easy to use, but we cannot describe complex pattern. We can only apply the first method on simple patterns, partial string matching. So that is use the like operator, comparison, like, like keyword, like, with partial string matching, only match part of the string, partial match, like. Special characters or pattern description. So like, how do we match partial string? Use this percent. This symbol, percent symbol, replaces arbitrary number of 0 or more characters. Here, you can see in Unix, we use star to represent 0 or arbitrary number of characters, right? Yeah. So we're familiar with the Unix way, but in SQL, we do not use star, we use percent. Percent, okay? 0 or more, any number of characters, percent can match that pattern. Okay, yeah, all right. use underscore. Yeah, here the underscore replaces a single character matching underscore. Okay, in Unix, single question mark, right? A question mark. But here we use underscore. In SQL, so different. Yeah. All right. Beware of the performance issue. Yeah. Yeah. So, all right, the performance. Yeah. So here, so let's just do, yeah, especially a large data amount. Yeah. Yeah. If you search, large, yeah, that could be a little slow. Yeah. Specify escape character. Escape. Yeah. Here also different from Unix or other programming language. Most of the programming language escape, we use backslash for escape, right? Yeah. In HTML, in many other programming language, in Java, we use backslash as the escape. But in SQL, you have the freedom to define escape character. But usually people use backslash. But you need to define it. Okay? Yeah. All right. And escape character is specified after the string using the keyword, escape keyword. So you declare it, then you use it as the escape operator. So you have freedom because sometimes you may not like to use the backslash as the escape character. Yeah. All right. Yeah. So in that way, you can define a different escape character. Yeah. Example. Look at this. Yeah. AB, after that, you want to, because the underscore, remember the underscore represent a single character pattern, but here you want to represent AB underscore CD, literal underscore. You want to display literal underscore. So you want to escape it using its original meaning, literal meaning. How to escape? So you use escape, that backslash, but you need to specify it. Okay, otherwise, DBMS does not know your escape is a special, still, yeah, DBMS does not treat a backslash as the escape character. Okay, yeah, all right, yeah. But here, regarding the special character, yeah, I need to give you one special example, special case, yeah, because it's important. Yeah, I need to let you know, yeah. Because later when you work by yourselves, it's quite common you may have the situation using that. Yeah, yeah. So what that is, look at the apostrophe symbol. Apostrophe symbol. We know to represent a string, we use a pair of single quotes, right? Single quotes or apostrophe symbol, the same, yeah. But here the question, suppose you have a string, that string contains apostrophe. For example, you want to represent string A, B, C, apostrophe S. Here, you want to use that literal apostrophe. You do not want to use because that apostrophe, it's a special meaning for string delimiter, right? Yeah, all right. In that situation in SQL, there is a special way to, although you may think about using the escape character, right? Yeah, but here SQL has its special way to tell DBMS this is apostrophe. It's not a string delimiter. Okay, double it. If you do it, all right, because we need to represent as a string, so we use a single quote A, B, C apostrophe, but this time you want to make it non-delimiter of the string. So apostrophe, apostrophe, double it, all right? That SQL will treat it as a single literal apostrophe, single one, literal one, all right? S apostrophe, okay? Yeah, yeah. So that's the, special way to represent a literal apostrophe, okay? Yeah. Because this case, you may have it frequently if you work in the real world applications. So you will need it. Okay, apostrophe. All right. Okay. All right. Then regular expression. Yeah, because today we only have 5 minutes left. Regular, yeah. So let's start a regular expression next time. So before we go there, I like to show you that percent, the usage. Okay, all right. So we only select, I only describe select condition. So where clause, yeah. Because suppose we have a query statement. Then where, in the where clause, okay, all right. So we need to describe, something, right? Yeah. For example, here I use address. Yeah. Because we know address is a string. Okay. Address like. Yeah, let's say like. Then, if we want to pick address start with, because the stream number address usually start with stream number, right? Yeah. 2, 3 stream number, the remaining, 0 or more characters. How about that? Okay. Yeah. So that's one example. Okay. Another, let me just give you a few more examples. Address like, let's separate with a space. Like, yeah. This time, suppose we want address contain Houston, for example, like % Houston. How about that? Okay. Left matching 0 or more characters before Houston, after Houston, 0 or more characters. So the Houston in the middle. All right. Yeah. So this kind of matching, simple partial matching. We use this way. Yeah. So this like operator usually for this kind of partial matching, left partial matching, right partial matching, middle partial matching, these 3 cases. Or you can join both left, both right, okay, yeah, or middle, right? So think about that, okay? Yeah, let me give you another third example. Address like start with A, 0 or more character, then match B in the middle, 0 or more character, at the end, C. How about that? Right? Yeah, that's the partial matching. Yeah. All right. Yeah, pretty easy. Yeah, but you can imagine this way, you cannot represent complex patterns. This way, you cannot represent complex patterns. Yeah. In order to represent complex patterns, I'll leave that topic next time. Regular expressions. In Unix, you learn the regular expressions, right? Pretty complicated. And actually, in most of the programming languages, most of the modern programming languages, you have a chance, or they all support regular expressions. So that part, use this chance, you learn, make it a little better. So next time we will go through commonly used ways of regular expressions, because in JavaScript, you can use regular expressions. In Java, you can use regular expressions. And in other programming languages, in the modern programming languages, so they all support regular expressions. So otherwise, when you describe complex patterns, very hard, very, very hard. All right, so let's do it next time.